In this video, we are going to look at the types of chemical reactions. So in the previous videos, we have discussed about physical and chemical change, and then we honed in into chemical reactions. And then when we look at chemical reactions, obviously one of the tool is to write a chemical equation. So that was the second video. We were looking at how to interpret or how to read correctly a chemical equation. This time we will take a look at the types of chemical reactions that we have. So these are the different types of chemical reactions. So you have a combination or synthesis reaction. So a combination or synthesis reaction happens when you have two different substances and then you combine them. That's why the name, and synthesize another substance, right? Decomposition is kind of like the opposite. You have one whole thing and then you are splitting them into two different substances. A single replacement is, well, like this, right? So it's like B and C are bonded together, A comes along, and then A replaces B. So now instead of BC, it's now AC. And now B is displaced. B is displaced. Instead of B being bonded to C, B is now displaced, and A replaces him or it. So that's why it's called a single replacement reaction. In other books, it's also called a single displacement reaction because it's really like that. One is displaced. A double replacement reaction is when they exchange partners. So you see, A is paired with B, but now A is not paired with B, right? And then if you look at C and D, C is paired with D, but now C is not paired with D. So as you can see from the colors here, they are exchanging partners. So those are the basic types of chemical reactions: combination or synthesis, decomposition, single replacement, and double replacement. Or again, in other books, single displacement or double displacement reactions. Okay, so let's look at some examples here. So combination, so remember this is the general case. So for example, you have here hydrogen gas and oxygen gas. They form water. So the thing to note here is that hydrogen has its own substance, oxygen has its own substance. But when they form and create water, water is just one new substance. It's not now two separate substances, it's now one new substance. So it is under the combination or synthesis reaction, right? For decomposition, it's the opposite. So for example, here you have Ni2O3. So this is one substance of nickel and oxygen, right? And then it breaks up and forms just nickel and oxygen gas. So this is a classic example of decomposition. One thing breaking up into smaller pieces. And then you have a single replacement reaction. And a single replacement reaction, remember, this is the general case. So for example, you have here zinc and COCl2, CuCl2, so copper chloride. What happens is the zinc now replaces the copper, and copper is displaced. So this is called a single displacement or single replacement reaction, or in some place just called replacement because one is replaced. When you say single replacement, it's not redundant, but what we mean is there's one that is replaced. So that's it. And then double displacement, some books also call it metathesis. This is when the positive and negative parts of the substances would exchange partners. So notice here that I'll annotate that with the colors just to emphasize. Notice that the potassium here is paired up with a bromine, right? And then this one, the silver, is paired up with an O3, right? And then now, where do you see the silver? Silver is not paired up with the NO3. The NO3 is actually here. And then the potassium is now here. The bromine is now here. So as you can clearly see, they exchanged partners, right? So pink, pink, blue, blue. Now it's blue and pink and blue and blue and pink. And they actually exchanged partners. Okay, so those are the four basic types of chemical reactions. But there are also, shall we say, special types. Okay, special types like combustion. So combustion reaction is the reaction that you do when you burn things. This is when oxygen combines with the hydrocarbon to form water and carbon dioxide. Note, combustion can loosely be thought of as a decomposition reaction because it breaks down longer hydrocarbons into smaller simple substances. So take note here that you have C8H18, which is octane. So the main ingredient in gasoline. When you add oxygen to it and you let them react, it becomes water and carbon dioxide. Okay, now why is this special? Special because for me, this is really just a decomposition reaction, right? Why do I say decomposition? Because if you look at this is a substance with how many players? With 36 atoms, or sorry, 26 atoms, right? Because you have 8 carbons and 18 hydrogens. So that's 16, carry 1, 26 atoms. So this is a big molecule, right? And then when it comes in contact with water, with oxygen, it now breaks down into water, which is H2O, which is just 3 atoms, and CO2, which is also just 3 atoms. So the way I see it is, I look at a substance and it's made up of 26 atoms. Now it's turns into substances that's only composed of 3 atoms and 3 atoms. So for me, that is still decomposition. It's not a straightforward one thing turns into two, but in the if you consider the size of the molecule, you have a big molecule and it decomposes into smaller molecules. So for me, this is still decomposition, right? But if you think of it as combustion is like a special case of decomposition. And how special is that? It's when it involves oxygen gas and hydrocarbon. So every time you have hydrocarbon and oxygen gas, it will always form water and carbon dioxide. And that's why we name it a different name, combustion. But again, technically speaking, it is a decomposition reaction. It's just that it happens a lot that we kind of make a specialized name for it, which is combustion. But again, it's just a decomposition reaction, bigger molecule being ripped apart into smaller molecules, so smaller substances. But it involves a special component, hydrocarbon and water, and hydrocarbon and oxygen. And every time you have hydrocarbon and oxygen, it actually creates water and carbon dioxide. And in fact, I just noticed it here. This is actually kind of wrong. I have to write the delta here to be more correct, because this doesn't proceed without heat. It should have a delta symbol here. But that's the idea. Combustion reaction is just a special decomposition reaction that involves hydrocarbon and water, and hydrocarbon and oxygen gas, and forms water and carbon dioxide. And then another special case is acid-base reaction, or we call it a neutralization reaction, right? This is a special kind of double displacement. So again, it's double displacement, just to let you realize that it's really double displacement. Remember, the H here is paired up with the chlorine, and then the sodium is paired up with the hydroxide. And then now, if you look at sodium, sodium is not paired up with this. And again, water, remember water, I can rewrite water as HOH, right? H2O is just HOH. So now what I'm really seeing is that the H here is this, and then the Cl is here, and then let's switch back to pink. So again, they have exchanged partners. So see, blue, blue, pink, pink. Now it's blue, pink, blue, pink. So they've exchanged partners. But again, it is, so technically speaking, an acid-base reaction is just a double displacement, but it involves an acid and a base. Okay, and what we name it like this because there's a special configuration. If it's an acid and a base, what is formed is always a salt and water. And I don't mean table salt. It means salt. It means it's a metal with a non-metal, right? So sodium is metal, chlorine is non-metal, so it's salt. So if it's a double displacement or double replacement reaction that involves acid and base, it will sure to form salt and water. That's why it's called neutralization. So you say you have an acid, you have a base, then when it reacts, it forms water, which is neutral, right? So it's a neutralization reaction. So in summary, there are four basic uh, types of chemical reaction. So you have the combination reaction, decomposition reaction, combination or synthesis reaction, decomposition reaction, single replacement or single displacement reaction, and then double displacement reaction. And then you have two special types. Combustion is like a decomposition reaction that specifically involves hydrocarbon and oxygen forming water and carbon dioxide. And then acid-base neutralization reaction is just a special kind of double displacement that has acid and base reacting to form salt and water. Okay, so that is it for the types of chemical reactions.